Welcome to the Profile Corner. In the last video we finished up the 3D Pantograph. We've got a little bit of a problem with it, kicking up all sorts of sawdust on the workbench and also into the shop air. I was planning to create a dust collection connection for the 3D Pantograph, but I couldn't quite figure out how to hook it up. I believe that I've got something worked out in the FreeCAD program that will allow me to do that. I've got to 3D print that model. Also, I did something that I did not plan to do. I purchased another router. I guess I need one of those like I need another hole in my head. But anyway, I purchased another trim router or palm router to take the place of the one that's in this pantograph. I need to get those 3D parts printed. Let's go up and take a look at the 3D printer now and let's monitor the progress of the printing. And then we can also take a look at the design process of creating those parts in FreeCAD. Just looking at real quick screen captures of the process. And then we'll come back once the printing is finished and we can assemble it onto the pantograph. The top layer finished printing on the 3D printer. It took about 2 hours and 13 minutes to print. This is the layer that goes right underneath the pantograph arm, and the dust hose directly connects to the outside of the cylinder that's on the top. Now I've got to get the lower piece printing. The bottom section's been printing for about 16 minutes, and it has about 3 hours and 10 minutes left before it finishes. I did a test fit up for the top piece and it fit the Festool dust extractor perfectly. One of the holes, however, cannot be used, so I'll have to drill another hole into this so I can get 4 screws securing it in place. Bottom section has about an hour to go before it's finished. The 3D printing of the bottom section is just about done. There's less than a minute left. It finished in 3 hours and 20 minutes. The printing's been going on for about an hour now, and it has less than a minute to go printing the front for the dust extractor. Your printing's complete. I have the three 3D printed parts here for the dust extraction connection, and I had to use a chisel on this section right here, and also right here, and also up inside these pockets to get rid of some support material that was added in by the Prusa slicer, so that this area up here could be printed, and also so that the area below the notches could also be printed. So after I did that, I was then able to insert the front into the pocket here, just like that, and it snaps in. And then the top assembly just sits on top. What I'll need to do is to super glue this top assembly onto the bottom assembly, and I should be able to do that now as long as my super glue hasn't fully hardened yet. So I've got some super glue here. I probably bought this a year or two ago, and I just recently opened it up and it's already pretty hard. And then I've got some accelerator. So let's see if we can get the top glued on. Looks like I still have a little bit of super glue in here that's not fully hardened yet. So that's a good sign. Okay, now I'll spray the accelerator onto the top piece. And now I've got to be very careful with the alignment to make sure I get it right. And it certainly doesn't take very long for this to set up with an accelerator. Okay, it's not a perfect alignment, but it's close enough. This screw hole right here will not be used, so I'll have to plug that somehow, and I'll have to drill in another screw hole, probably right in through here, so that I can have 4 of these screws holding this on to the bottom of the arm. So I'll go ahead and I'll drill another hole right now. I pulled the pins that hold the arm onto the mount so that I'm able to secure the 3D printed part onto the bottom side here. I've got some 2.5-inch screws. I had to widen out the pilot holes for the screws to 5/32, and now I should be able to just drive these in a little bit to make an indent in the bottom of this, and then I should be able to pre-drill for the holes for the screws after I do that. It looks like it's in the right position right now. Okay, so I've got some holes marked in the bottom now that I can drill out. And then once I do that, I'll bring the camera back and we can mount this in place. I just drove in the screws. I didn't bother countersinking these holes because this plastic is not really that thick. And so I've got it in place. And by the way, you may not want to use super glue as I used here. You may want to use 5-minute epoxy instead. As I was driving in some of these screws, the screws didn't go in real straight. It hit the top portion and that broke the super glue bond. I don't think that's going to be a problem because we've got the screws holding it together right now. So now I should be able to put on this front piece. Okay, that snaps into place nicely. That's good. And now I can get this arm repinned in. And that should just take a couple minutes here. You know, I added in a 2x20 board here and also here. And I used MicroJig hardware to keep it in place. So this should make it so that the board cannot shift back and forth this way while I'm doing the cuts. I'm set up here to do the large spiral. So let's go ahead and give this dust collection a shot. I don't have the broom on the bottom here, but there won't be a whole lot of clearance for it anyway, so it may not make any difference. Yeah, the dust collection seems to be working pretty effectively. I don't have a whole lot of dust all over the place here. There's a little bit. I don't have the bit set quite deep enough. Let's try to change that. Okay, we'll give it another shot here. That looks a little bit better. I think we can do even better than that. That's more like what I was looking for. So that looks pretty good. Let's try the smaller spiral that's right next to it. And that seemed to have worked out pretty nicely. And I didn't get a whole lot of dust. I am getting a little bit of dust, but it's much less than before. Okay, so that seems to be working pretty well. Let's take this off and we can see how well we did. Okay, here's a close-up view. This is a small spiral and the larger spiral. And of course you can create even larger spirals using a computer to generate that. Or you can do what I saw Matthias do, and he just created a post here in the center. It was maybe a 1/2 inch in diameter, and then he wrapped that post with some string that's non-stretchable. And then he tied that onto the follower right here. And so he would start out maybe way out here. And then every time he made a revolution, more of the string would get wrapped around the post that's in the center until you end up at a very small spot right in the center of the spiral. So that's another way that you can do a spiral. What I'd like to do now is to show you some video clips of me creating the smaller spiral that's right here, and also another template that's similar to this one here. It's not quite the same as one of these, but it's the same idea to create them. Let's try to create a quick spiral template for the Pantograph. We'll start out with creating a new body. what we need to do is we need to change from part design to part. And now we've got some additional items here on the toolbar, and we want to use the create primitives. So we'll click that, and now we can pick our geometric primitive that we want, and we want to use a spiral. And now we can set the properties for it, and I'll set the growth at 14. Okay, I want 2 spirals, or 2 rotations, and I want the radius to be 1. I click on create, and there's the first spiral. Now we need a second spiral just like that one, except that it has to have some different parameters here. I believe that the radius to use a 10 millimeter fouler needs to be 10.150. Considering that the other radius is 1, this may actually need to be 11.15. And we'll create that one, and now we can close that. Okay, next what we need to do is we need to highlight both of these, and then we'll change from part up here. Remember, it's normally on part design at this point, and we'll change that to draft. And now we can go to modification, and then we can select draft to sketch. Okay, and that has created a sketch, as you can see here. And now we can drag that sketch into the body, which is the 3D model that we created earlier. And if we expand that body, and then what we can do is we can hide these 2 original spirals here, and then we can double click on the sketch to go into it. Now this looks a little bit complicated in here, but it's not really. The spiral is here, and that's all that we're concerned about. Okay, so I want to create a couple of arcs that connect these endpoints, so I need to change to a different style arc using the 3 points. So now I'll click on the endpoint, click on the other endpoint, and then I can just move down to set the 3rd point, and I'll do the same thing here. Click on the endpoint, click on the other endpoint, drag it out. Okay, now that we've got that, we need to create a rectangle around the spiral so that we can then convert this into a 3D model. Okay, so we can make it looks like 75, and I'll hit the tab key, and we can make the other dimension 66. Okay, now that's been set. Now we can close the drawing, and there's our sketch. Okay, now we can convert that sketch into a 3D model. We'll have to change from draft back to part design. Let's try padding it. We'll go to pad, and then we can set the depth to 8. Click OK, and that way we don't use quite so much plastic. And now we've got essentially a 3D model here, but there's no back to it. So we can't use that on the
Pantograph
template holder yet. We have to put a back on it. And so what we can do is we can go over to the side here, and then we can create a sketch at that point. And now what we can do is we can just draw in a rectangle, starting here, going across. Okay, we want to make the rectangle as wide as the other portion, so we'll make that 66. And then we can set the height here to, let's say, 3. Potentially zooming in a little bit here. Unfortunately, I didn't set the center line of the rectangle that surrounds our spiral to a fixed distance from the origin. So let's maybe fix that. We'll go to close, and then we can go back to our sketch that we use for the pad operation. So we'll zoom in a little bit, and then we'll measure from this point here down to the origin. We've got to be able to see the origin so that FreeCAD doesn't get confused. And now we can set that to 29, because it defaulted to 29.08. So we'll go to 29. Okay, now we know that distance is 29. And now we can go back to our sketch. And that's this distance here from this center to that location right there. So we'll go from this location to the center. And that needs to be 29. Okay, now we can close this. And then we can pad that. So we've got the sketch highlighted here. And we go to pad. And now we can make that whatever this distance was. And we may have to reverse it. And there we can see that we're getting close. And we need to extend this length out a little bit more. I don't recall what the length needed to be. 76 is too much. Let's go back to 74. 74 is too little, so let's go to 75. So let's go to 75. Okay, now we can click on OK. Okay, so now we've got essentially a template. And then all that you've got to do is add in a screw hole here. And then over on the side, you need to add in a V that's 2.15 equilateral triangle. And then you can pocket that into the side and use that for an alignment block. Okay, so now that we've got this set, let's see if we can't create something else that's a little bit interesting. Let's create a new body. So we'll click back over here to the side, and then we can actually hide the one that we're looking at. And now we'll create another body. Okay, we've got the body created. Next, what we need to do is we need to create a sketch on that body on the XY plane. And what I'll do is I'll just create a simple rectangle. I'll center it on the origin. I'll just right-click to turn off the tool. Pick the corner points that are diagonal to each other, the center point. And then what I can do is I can say that those are going to be symmetric. Okay, so now I need to set these dimensions.
we'll set that to 48, and we'll set this one to 48. Okay, we click on close, and now we can pad that, and I'm going to make it 8 for the pad. And now that we've got that, we can create another sketch on the face. So I clicked on the face, and now we'll go to the sketch, and then we can use maybe an arc created by 3 points. Okay, now I'll create another arc by 3 points. Okay, so now that I've got that, let's set a couple dimensions here. Okay, and now let's set. Okay, we'll set that dimension to 10. Okay, let's do this one next. Okay, we'll leave that at 9. And now we still have 4 undefined constraints. Okay, let's set the height here. We'll set the height of this one. Okay, so now we've got to set the distance from the origin. Okay, I'll say that that's close enough. Okay, now that we've got our sketch, we need to create a pocketing operation. So we'll pocket down 5 millimeters, which is the default. Click OK. And then what we can do is we can highlight that pocketing operation. And then what we can do is we can go to this polar pattern. And now we can specify the number of those we want to have up here. Let's try 5. And that's kind of interesting. Let's try 4. And that kind of looks like a clover. And now we can close that window using the OK button. Okay, so that's kind of an interesting thing that you can do. And obviously we'd end up wasting a lot of plastic. And so what we can do is we can radius these corners just by using the fillet operation. Let's see if we can go to 20 for that. Okay, that got rid of a lot. Let's click on this other corner here after we click on OK. Let's click on the other corner here. And then we'll use that same fillet operation again. 20. Okay, we'll spin this around so that we can see the other side. Okay, so now that we've got that set, maybe what we want to have here is a center indicator so that we can position this on the template holder at a certain location. So let's create another sketch there. And now what we can do is we can just use a polyline. We'll go up, come down to the origin, back up, back down, and then we'll connect our starting point. And then we can right-click to get rid of that tool. And now we can go through and then we can set dimensions. That'll be 1. And we've got a redundant constraint that we've got to get rid of. That was automatically created for us. Okay, so let's try this again. Let's give that a measurement of 1. Okay, we'll have to zoom in a little bit more to see it. Give that a measurement of 1. We'll say that this measurement is going to be 2. Okay, now we've got a little bit of a problem. We've got to say that from here to here, it's going to be 1. And then we've got to make this line here vertical. Okay, so I'll go to this open area here, right-click to get rid of that tool. I can click on this line, and then I can use the vertical option here. And it says that we're over-constrained with number 10 and number 14. So get rid of number 10. Actually, we can get rid of number 14. And let's help this out. Let's bring this point in. And now we can try to do it again here. We'll click on that line, and then we'll say that it's vertical. Okay, now we're fully constrained. Click on close, and then what we can do is we can use a pocketing operation. Let's spin around to the back side. Okay, and we'll go all the way across. And then we can click on OK. And now we can rotate, and we can see. And now we've got an indicator there for the center position. And then we can go to this face here, create another sketch. And then we can create a screw hole just using a circle. Start it at the origin, and we'll say that that is 3.98. Okay, now we can close. And we can create a screw hole by using a pocketing operation on that sketch. And then we can go all the way through. And now if we rotate around to the back side, we should then be able to see the hole goes all the way through. Okay, so that's the basics of creating templates for the
Pantograph.
using this FreeCAD software. You got to keep in mind that the template followers have to be able to fit into here. One of the template followers is 10 millimeters, and so you've got to allow 10.15 millimeters of space for it to get through the different sections. Of course, the back end of the of the template fouler is 6 millimeters, and so you can allow 6.15 millimeters for that to pass through. And of course, you can also use a 12 millimeter fouler or a 15 millimeter fouler on the inside.
That's all for today. Thanks for watching. Bye.